the inverter convert the DC current, positive and negative DC coming from the battery, into AC power, hot, neutral and ground for single phase, or hot, neutral and ground for double phase or three phase. This is an equipment, this is an expensive equipment with an special characteristics. We are going to study in details how the AC power is produced on the inverter. Suppose that this is the DC signal, that's the positive side of the DC signal, and this is the negative, voltage and time. If you interrupt the positive signal in sections, if you cut the signal with the transistors and capacitors, the positive and the negative with transistors and capacitors, you cut it, and after that you pass that current, interrupted current, through a coil, and the coil is the primary coil of one step-up transformer. Depending of the quality of the inverter is the output signal. There are inverters with high quality, but those inverters are expensive inverters. And there are inverters, cheaper inverters. Those inverters produce triangle signals or square signals. I am going to explain the procedure to calculate the capacity of the inverters in kilowatts, and I am going to explain the procedure to install the inverter on the boat. Remember, the inverter is one of the three sources of AC power. One source of AC power is the shore power, the second one is the generator, and the third one is the inverter. The inverter, normally, this is the typical connection of the inverter. The inverter at the input receives power from the group of batteries. The group of batteries, they have a main switch. This is the switch. It's a typical main breaker or main switch like this. In order to connect and disconnect the power, the input power DC to the inverter. The input power DC enter into the inverter, and the inverter convert the power into AC power. That source of AC power goes into the switch selector in the position inverter. There are other positions for shore power and other positions for generator. Okay, in this particular case, the DC power is converted into AC and enter in the position inverter. How can I add it 20% easily? Okay, the recommendation is, okay, we are going to divide it, no for 24, we are going to divide it for 20, and this is the safety factor. Okay, it's 20,000 divided by 20, 1,000 amps. This is the amount of amps that I need at the input of the inverter in order to produce 20 kilowatts in the output. 1,000 amps in order to produce power for 1 hour. Oh, I need those equipments working constantly for 3 hours. You need 3,000 amps. Normally, the inverters, the marine inverters, they have on the label, they have the label, the inverter, the label says inverter / charger. And normally, if you check the AC panel of any boat, if you check the AC panel, this is the AC panel. The power from the AC panel is coming from the switch selector. The switch selector receives power from inverter or from shore power or from generator. Okay, normally in a typical boat, on the AC panel you found that one breaker with the label inverter / charger. For example, this battery is a Series HD. This battery is an excellent battery. This battery have a capacity of 800 amps per hour. It's a good capacity. Or those batteries are Series 27. Those batteries only have 100 amps per hour. Oh, in this particular example, I need 1,000 amps per hour. Okay, with two batteries of this, I have 1,600 amps per hour. This is a good selection. The secret is select the appropriate batteries in order to keep a good group of batteries properly installed, properly organized, in order to supply the amount of AC power required for the customer in the boat. Other important recommendation is install the inverter separate as close as possible to the battery bank, but not over the battery bank. It's logic because if you install the inverter over the battery bank, the gases, the fumes from the batteries affect the circuit boards on the inverter.